Hello everyone, welcome back. So we are starting a little bit, and I see that a little bit later today, and let me adjust here let me adjust here what's happening here. Wait a minute. Let me just adjust the camera, move it down a bit. Yeah, that's better. But yeah, I don't know what was happening. I was just also at last minute adjusting the sound. I did a recording check that it actually, I see what happens. The camera, I adjust the camera and it keeps slipping off. Okay, let's see if this holds down. Yeah, so I also adjusted the sound so we won't have any issues like last time where the sound was incorrect for the whole stream and then I really only noticed it much later. So a couple of other items. So I am I will be at ISMB in July. So if anyone who hears this streams is there, I'll be very happy to meet. I'm also going to then, on the way back home, I will going to spend a few days in San Francisco. So because when you're in Australia, if you go somewhere, you might as well take the advantage of that to try to do multiple things in the same trip. So I'll be in San Francisco for a few days. I have already a couple of things scheduled over there, meeting some collaborators and some people I've worked with, and I'm still trying to adjust this camera without messing up everything. Okay, I should get a proper setup one of these days. Basically I'm using my phone on a tripod and the tripod keeps slipping. So I set it, it looks okay, and then immediately after I put it down, it slips. So I'm gonna rotate. Yeah. Because and I always have to find a position where it's as much as possible in front of the screen without actually being in front of the screen, because I still do want to see the screen. Actually, I don't know what people do. It could be just on top of the screen, I guess would be ideal. So maybe I should just buy one of those that you can fasten on top of the screen and not have to set it up every single time as I do now. Anyway, that was enough intro. So if you're going to be at ISMB, that's in Montreal, or if you're just in Montreal for any reason around July 11 to July 19, or July 18, or then in San Francisco from July 19 to 23rd, drop me a note. I'll be happy to get you coffee, or we can get coffee together. We can chat science, we can chat about extremely open science, we can chat about sardine, we can chat about anything we do at all. Anyway, so all of those out of the way. Not sure I played the intro music. I'll play it now. And yeah, so let's get right to where we were last time. So here I still have even the window, the same window we had last time. So just a quick recap. Oh, we didn't. Guess I forgot to. Even forgot to commit. Okay, I guess this was, I added a little bit of more information to the README file. All right. So what did we do last time? So last time, first of all, we talked quite extensively about what the project was going to be, what we were going to be doing, etc. And then we started this. They said we were going to call it sardine, spelled with a Y, in the, I guess, it's now tradition, sardine being the second one, of using old-fashioned spellings of common fish for our projects. This building on Mackerel, which was or is actually our tool. That looks for AMPs in genomic data or metagenomes. And that's an old-fashioned spelling of mackerel. And so here we have the old-fashioned spelling of sardine. Right? And then we discussed the basic idea, and then we said the first thing we were going to do is do a very simple simulation study whereby we're going to download the genome. And here we decided to start with this genome, which is the genome of E. coli K12, probably by far the best genome, or at least one of the best genomes, most widely studied genome. At least when it comes to bacteria, I guess the most widely studied genome is the human genome, but when it comes to bacteria, E. coli is probably up there. And so we would start with this very, very good genome, and then just mutate it in silico and see what happens to metrics of quality. So the first thing we're going to do is actually, let's just load the genome into memory. Okay, since this is a FASTA file, I didn't mention mackerel, so I'm gonna borrow this. By borrow, I mean literally just copy this FASTA reader, which is a very simple, I guess it's not even properly documented. Actually, I think this is slightly older version, because it only supports JZip. I'm gonna copy the one from Semibin, slightly. Yeah, all right, it's a little bit better, yeah. So it iterates over a FASTA file, and it returns each individual config once with its, so it returns the sequence and the header, and it does the uncompressing if needed, so basically based on the file name. So this is, I mean, I normally prefer not to use BioPython if I don't have to, if it's just about loading the FASTA files, because that brings in, a bunch of other dependencies that I might not want. Okay, so let's start this. I don't actually see the bottom of the screen. Is it FASTA Terra or Terry? So there should be a single sequence, and the length of its sequence should be this, which is 4.6 million base pairs. So this is the sort of the length of the E. coli genome. Okay, so basically just so let's do this one thing, and I showed you. So what I mentioned last time. So what we want to do is we're going to be mutating this genome and seeing how well tools like CheckM2, how good they think it is. So let's first just run CheckM2 on it. So CheckM. So this is CheckM. Okay, so I'm gonna So as we saw last week, so checkm2, you need to use a relatively old version of Python, and so I decided that we are going to, let me adjust the camera one last time. We decided, as this is solving, we decided that we were going to use a separate environment for it. So I'm going to call it checkm2. So there it is, installing checkm2. Because we will be using it as a and now we will run this genome on checkm2. So let's see what it says. I don't have 30 threads. I'm gonna use only 8 because otherwise, and this is what I've seen in the past often on stream, is that we end up with, because I'm simultaneously running OBS and the whole streaming thing, everything is very, very slow on stream, whereas it would be much, much faster. Let me go. It will be much, much faster without it. So it's well. Okay, I guess. Guess we should be writing this stuff down. Okay, so for now, I'm gonna edit here. Not dogs. Sorry, that's a different project. Notes. I'm just going to copy the stuff we wrote here to then. Okay, this is going to take a few minutes, and it might take. So my internet here is, it's not amazing. It's 7 megabytes per second, but it's still pretty good. I mean, so if you have a more mediocre connection, this might take a while. If you're lucky enough, maybe you live in Korea and you are internally making fun of me for how slow my internet is. But here in Australia, it's rarely very, very fast. So that's. But anyway, well, let's see. Let's hope that this will finish in a few minutes. In the meanwhile, this. Okay, yeah, I mean, in this case, Copilot is actually pretty good. Okay, so the other thing we will do, did we install Prodigal or not? Prodigal, yes. The other thing we will do, as we said we did, we will run Prodigal as well. And Prodigal, I mean, I've run this many times, obviously, but I always have, I always have to, so -I. Does this work? No. This would work. I always have to figure out the let's do this. So right now I'm just you know I'm just running this on the command line. So just trying to figure out how it would work. I'm not really okay. This is not really something I would ever actually use. Okay, it's actually pretty good. It's pretty okay. Alright, so this worked. Okay. Oh, check it. So I'm sort of going back and forth between the two windows. So this very well. Okay, this is running here, so I'm going to write a bit of code to do this thing I did in Python. Let's do it in this thing I did on command line. Let's do it in Python. Dev run. And I am actually going to use Prodigal rather than Pyrodigal for now, at least, because checkm2 also wants Prodigal. So just to avoid any issues. Okay, something like this, yeah. So here we need to run two sub-processes in Python, one of which will be the zcat process, and the other one will be the actual product. So we need something like this. Something like this, where so we So protocol ran really fast. So since sorry, I'm cleaning the camera now again. Protocol ran really fast. So maybe I don't need to save the something like this. Maybe I don't need to, I don't need to save that. See what it did. Yeah. I know where this, I don't need to. Let's see, what do I actually want to save from? Okay. Okay, check M2 is still running. So if all I care about is the average size of genes, then this would work. Okay. This would work. Yeah, so. Okay, that's pretty good. Let me get rid of the let's do this. Okay, so we could do this. So this would just compute the gene sizes, and then we could do this. I think so. Okay, so the average gene size is 314. Exactly. Oh yeah, I was checking the amino acid. Okay, let's check the nucleotide. It's a little bit more. Not sure exactly. Maybe the amino acid is a little bit more natural. I'm more used to thinking in terms of ORF, so I'm a little bit more used to thinking. Yeah, 942. Oh, sorry. So it's pretty good. Pretty good. Let's do. So we have, all right, okay, so we have that. Let's see how we're doing on time. Okay, so we're about halfway through. Yeah. So, all right, so maybe I'm gonna aim for, at the end of this, to have, you know, an initial simulation of mutating the sequence and then running it. So how do we mutate the sequence? So we have the sequence. All right, let's do this in a very, very simplistic way for now. So we have we choose a position, and then we choose an operation, and then we execute it. So position would be random sample. Yeah, so the rand int gives, it should be like this, because rand int is stupid. Alright, now we choose an operation. Let's do it like this. Insertion. Something like this. Yeah, this sounds good. Except let's do this. Let's do it like this. So yep. Okay, this even has Alright, so that's I don't know if it matters. So I'm gonna save this for It's pretty fast. Okay, so let's do this. Okay, so we can create a mutated sequence. So we could do this. Okay, great. So yeah, so introducing mutations made the gene, call it the average gene drop, size drop. All right, this is pretty great. All right, so so let's just do this again. Let's do this. Okay. Right, so this will create the sequence after n mutations, and so now we can do sizes dated. Okay, something's wrong here. Yeah, okay. One day this will hold. I'll figure this out. Okay, we can do this. Let's do this. Okay, this is a little bit bad in terms of efficiency, but since this seems to run quite fast, it might actually finish. So let's see what we get. Okay, there it is. So we have right, so this is the original. So now we're gonna just create mutations, and there you go. One mutation and we already lost a gene. Alright, so this. Alright, so we lose. Alright, this is pretty cool. Okay, in the meanwhile, check M2 actually finished. But before we let me think about this. It's gonna take a while. So let's actually interrupt this. Okay. Alright, so I'm doing this okay, and I'm gonna turn this into a jug file because this is okay, Okay, this is a little bit messy, so I'm going to start cleaning up. All right, so this function is good. Okay, this is fine. Function is good. We're keeping it. This stuff let's save it at the end. Mutate multi. Okay, brilliant. Okay. I'm going to go back to source. Okay. So the task generators are going to be the ones that are at the highest level. So I mean the ones that will be going to be called. So E. coli. There you go. Okay, so this into a task generator. Okay, so this is a little bit. Right. So okay, let's see how we are on time. Okay, so I did this a little bit hastily, but this is the basic idea. So we create the. So this is now relatively standard. Jugs file type of thing. We created normally we start we declare our functions, our task generators. Some of these helpers look more like functions. Some of them are just standard functions. And then some of them are task generators, which we will use then at the bottom of the file, just calling them. Yeah. And now, so now this. Yeah. So this will. Yeah, all right, so this works. We could probably optimize this quite a lot, and this will also, for better or for worse, it's going to use a lot of disk space, but I mean, it probably will work for now. Okay, so I'm gonna run multiple of these, and now it's running in the background. Maybe do something like this. Okay. Yeah. So jug, if you create this file, jug, please stop running. Actually, __ jug_, please stop running. Exactly the name like this. Then jug will stop running. It will take just a little bit because it will not interrupt anything that's any ongoing processes, but it will. The next time it's going to run a task, it checks, oh, this file exists, so I'm not going to run the new tasks. I'm just going to end. So the only reason I'm doing this is let's just run 5% of the data set right now, or 5% of the simulations. And man, one day this, I promise you, one day this, 5% of the simulations, and that will this will allow us to, at the very least, do we have IPython? At the very least, will allow us to do a quick plot, and then I will run the rest of it offline. And literally, normally, I don't like to do too much on the EOS project offline, but in this case, I will just running things is perfectly acceptable. So now, so a lot of things are running at the same time. So simulation, the OBS stream, the record, or not the recording, but the streaming, all of this at the same time. It's a lot for a little machine, but in the meanwhile, also check M2 finished. Okay, and I don't know, it looked okay. We actually didn't. I guess there's a lot running at the same time. So there's OBS, several jug processes, Prodigal. Alright, but yes, so IPython, we're downloading IPython. Oh, guess we have matplotlib. Let's see. Okay, it's mostly done. So let's make sure we save the files. So we save these results. Okay. Okay. There it is, average gene size as a function of the number of mutations. And okay, so this is one of the things we had seen before. The other thing we would like to see, however, is the checkm2 completion. So the checkm2 completion, same principle. It's just gonna take a little bit longer to run, and so that will probably have to be done next week, because yes, we are now running out of time. But as you can see, this is what we had seen, is that as we increase the mutations, and so here 400 mutations. This is in the 4 megabase per genome. So this is not a lot. So yeah. So let's see. Let's just start cleaning up a bit. Where am I? Yeah. Cleaning up a bit, so I can remove this. Okay, yes, indeed. Okay, I'm gonna just run some as I. Add the simulation. I'm going to add the FASTA file because obviously we need that one. This mutated. Yep, we don't. Okay, I guess it's probably checkm2 is running those things. Let's ignore that for now. Yep. Alright, so okay, so this was actually quite productive. I mean, this was a very simplistic model of mutations, but good enough for now. We can always change it later. Now that we have this architecture. I'm gonna pet peeve, don't have spaces at the end of no spaces at the end of lines. No. we also need IPython. I'm going to add it there. Yeah, so in this case we installed it later, but let's retcon this into saying we had it. Install. Yeah, IPython. So we use Jug Shell, which I did very quickly, but that requires IPython. Stream notes. So today, sorry, did I mess this up? Yep, I messed this up. So first of all, this is 5, and today is. Okay. Yeah, I'll have to add the links later, but let's add some nodes. So. So this will be the next step. Right, so I think I mentioned this before. We had this graph that Anna Kruskov put together. So within a genome, the average size of genes, we thought that it goes down, and so within that genome, it's fair to say that the longer genes are an indicator of better quality genome. But if you look across genomes, that's no longer true. Some taxa just have longer genes, and so this is not a metric that we can use agnostically to the taxonomy. So we will be looking at this CheckM2 estimates of quality for that. So there. Okay. Also, we have fixed states. So next time we will be doing exactly the same, except we will run CheckM2 on all of these things. So you can see already. All right. So we saw how CheckM2 runs, and see this quality report. So name, completeness, 100%. Okay, yes, this is a 100%, 0% contamination. So this is a very good average gene length. Okay, it also outputs the average gene length, which I guess, we're not the only ones to think about these things, obviously. GC content. All right, so we would do this. We would do this for the simulated genomes, in fact, I think. Okay. All right, so in the meanwhile, this is running. Sorry, wrong. So this is also running, creating all of these simulations. So it's gonna. So it's not that it's pretty fast. I mean, it's only running 4 processes, and it's already 14% or 15% of the way. So we could do this much faster and more efficiently, but it's really not worth the effort of doing so. So just before I log off, I am going to just run a bunch of these at the same time. So and the results will be done in less than an hour, and then I will actually generate full plot and maybe share it on the mailing list. But it will be basically doing what I showed before. So with that, let's push everything. One last check, is everything okay? Oh. Alright, one last check, everything's okay over there. So, alright, so I think we didn't have alright, so I'll do a recap video later today as well. I'll post the plot on the mailing list once it's finished running, and then next week we will run CheckM2 on all the simulations, or at least some of them, and see how ideally CheckM2's measure of quality, the completeness will start to go down in the same way that we see that we are missing genes, and that's the effect we're looking for. So with that, I'm wrapping up. So any questions, anything, just feel free to reach out, comment below. Subscribe to the channel. If you're in Montreal or for ASMB, or in San Francisco around July 19th to 23rd, just let me know. We can get coffee, chat science. And so with all of that, I hope to see you soon. See you next week here, same place, same time.